Pete says I'm Allistair Wilkinson. I'm the Technical and Innovation Manager at CEMCOR, and I'll be just slightly different context to previous presentations, but kind of showing the route from what was essentially for me started as an academic journey, starting my PhD 10 years ago, and now in the industry, taking that academic research and really bring it to reality and bringing new low carbon cement products to the market. So, just very briefly, we'll go through an outline, but I'm sure a lot of people on the webinar won't be aware of who CEMCOR are. A bit of a background to calcined clay, what it is, and why this is the horse we've picked to back as such. A bit of an update on our the development process, how we've got to where we've got to, the trial data behind that, and really next steps and future development for the project. So, CEMCOR, we're a independent cement company in Northern Ireland. We are an ex-Lafarge plant, historically Blue Circle. So, new name in the market. The plant was purchased by CEMCOR in 2022, but we've been operating here at Cookstown for 57 years now. So, a long time in the game and a lot of experience in that cement production market. So our main operation is at Cookstown in the middle of Northern Ireland here. So we have a cement plant supported by the limestone quarry, where at the moment 90 to 95% of our raw materials coming from. We also have a second quarry in Dungannon, which is about 7 miles away from the plant, which provides the rest of the raw materials. So the clay for the clinkering process here at Cookstown. And the final kind of piece of the jigsaw is an import-export facility in Belfast Harbour. We import white cement from Europe, but also export our grey cement across the UK and into the Republic of Ireland. So at CEMCOR, our tagline is setting the standard. And really, there's four main areas where we try to set the standard as such. So cement is our game. It's something we've been at a long time. So naturally, that's the core of our business. We're also developing specialist and DIY products and DIY cements. Very active R&D operation here at Cookstown. But the main one that I want to be talking to you today is about CalcinX. So CalcinX for us is we view it as a groundbreaking development for the industry. It's essentially a low carbon clinker alternative, and we're the first cement company in the UK and Ireland to have done any real meaningful work at great scale with this. So where we're able to come from here is have waste materials that are available locally to us, waste clays, low grade materials that aren't useful certainly not useful for aggregates, not useful for cement manufacturing, and really repurpose these materials in a manner that creates a cost-effective solution for alternative cements and supplementary cementitious materials. Most importantly for us, that's reducing the reliance on imports. So really, you've got the likes of GGBS and fly ash that are out there at the moment. We're coming from a different angle on it. Fly ash is obviously going to become more difficult with coal power plants closing down, and the last of which closed in the UK last September. And GGBS, it's a fully utilised market, so we're trying to add something different to really help drive forward the carbon reduction in the cement and concrete industry. So the calcined clay is essentially the result of a low temperature calcination of alumina-rich clays. So we're looking for components like kaolinite, illite, just clay-rich materials with a lot of alumina there. The lower calcination temperatures, essentially what we're trying to do is remove the structural water and do no more than that. So we're looking at temperatures of 850 degrees compared to 1450 degrees for conventional clinkers. So this, combined with having no calcium carbonate in the raw material, means that we can really drive that CO2 number down, but create a very reactive cementitious product. So the studies to date, we've seen a CO2 reduction of more than 70% compared with clinker. Within the current standards, so we're not going out on the limb and creating a totally new unknown material that people haven't heard of. Calcined clay is classed as a calcined pozzolan in current cement standards, and is also accepted at some level in BS 8500 into the concrete standards. So really, we're trying to bring something new to the market, but keep it familiar and keep it within existing standards. So why calcined clay? So for us, in our opinion, this is the most effective means of us as a company reducing our CO2 emissions. Uh, the GGBS market is well established and a lot of big players, so it's not really in our interest to get involved with that side of things. Equally, fly ash, other issues with long-term supply there. So really, we're very focused on materials that are within our control, locally available, and really start to reduce that reliance on imported materials and materials from that are byproducts from other massively intensive, energy intensive industries. So it's all about security of supply and providing that long-term security of supply for the industry, because we all know that there's going to be more and more concrete poured on an annual basis, whether it be new builds, retrofitting of existing structures, and renovation work. So the pressure is really going to start to come in the coming years to decarbonate concrete while using quite a lot of material. So kind of the market research for us behind this is that we're forecasting, and through the work and Pete and colleagues of Pete have been working on, we see a significant demand forecast for the coming years, potentially more than 3 million tons per year. Overall, there is a demand for supplementary cementitious materials, but there's a huge demand for a long-term security of supply, which other materials, there's no guarantees maybe in 20, 25 years' time. There's huge opportunities to take waste streams that are currently destined to landfill, whether it's overburdens from quarries that's maybe going to a tip for restoration works or to fill a hole somewhere, or to conventional landfill as we know it. These are the types of materials that can really potentially make a change to our industry. And there's a developing interest in clinker-free cements and very low carbon materials. It's still relatively niche at the moment, but depending on your application, for instance, your resistance requirements, whether it's chloride, sulfate, for very, very problematic site locations, clinker-free cements can provide a range of properties that conventional Portland cements, no matter how you blend it, really can't achieve. So really, the development process, we're kind of in phase 5 of our research project, if you like. So phase 1, for me personally, started, say, back in 2014 with starting my PhD. Started with Lafarge at the time as a lab technician. So really, that's when we started to look into the potential to roll this out towards wider industry. That development really kicked off when CEMCOR bought the plant. So we spent pretty much all of 2022 and the early part of 2023 analysing a variety of raw clays that were available directly to us within our existing quarrying systems. Phase 2 then sees us try an initial 800 ton trial. Could we grind the material through our existing processing plant here at Cookstown, and could we calcine it? So everything we've done so far on an industrial scale has been done with our existing infrastructure, with no mechanical modifications, no huge investments in new equipment. We really wanted to prove the concept that not only can we make a low carbon cement and cementitious product, but we can do it without spending tens of millions on new plant. We then followed that up with a second major trial, and following that, we spent about 8 to 10 months on doing some further lab work on various blends of cements, trying to get performance up, seeing what we needed to do, and really start to define optimized running parameters. The current phase of the project then, we're currently in the middle of a Innovate UK funded project, so just under £500,000. That's allowing us to work with Queen's University in Belfast, with the team there, who have fantastic knowledge in calcined clays and certainly in the local geology, and helping us identify the types of properties we need to be looking for. We're also working with 2 customers, so Tobermore, who are a precast paving company, and Moore Concrete, who are more of a traditional precaster. So at this stage, the project's progressing really well, and we're currently working through the third work package of that project, which is developing a clinker-free cement using the calcined clay. So just to go into some now trial data and more mechanical strength workability properties. So we've taken CEM1, CEM2, conventional readily available cements, and used those as our baselines. So all the data here, this is using either a replacement of CEM1 or replacement of CEM2 blended together, no additives, no specialist admixtures, straight direct replacement essentially. So what we found was that with the 50% CEM1 replacement, we're able to hit in towards a 52.5 strength class. So falling within the boundaries of what most of the CEM2s on the market are. So getting decent early strength, but really starting to see that strength develop over the longer period of time. We then started to look into replacement of CEM2s, where we also had limestone filler in the mix. So really, that's where you start to maximize your carbon benefit there with that blend of calcined clay and the limestone filler. Again, seeing very similar properties with 30% CEM2 replacement. Clinker contents were quite similar, but what we're actually seeing was a better late strength and pushing us up into the higher strength classes. Most importantly for us, we're always comparing with CEM1 and GGBS because that's kind of the industry norm, almost certainly in Northern Ireland, for a low carbon cement at the moment. And really, we're seeing the big benefits. We're achieving very similar late strengths, but that early strength development is something that's looking very promising. And any precast customers that we're talking with and trying to work with are very interested in it. Strength activity index typically done with 20% replacement, but yeah, we're seeing really good strength activity. Workability in a similar fashion are initial setting times, nothing too out of the way. We're seeing a 50% CEM1 replacement is actually very similar to our reference CEM2 cements. Water demand, kind of a problem that's known with calcined clays, but again, seeing no major concerns there. Things we can work on, things we can tweak and refine. But for us, for a first attempt at this at a scale, something we were pleasantly surprised by. We then developed a blended product. So compared with the 50% CEM1 replacement, we've developed a CEM4B, which is 50% clinker co-ground with 50% calcined clay. And the big difference there, we're seeing a much better strength development in 2 days. So it's interesting to see the difference between a blended product and a co-ground product and how that actually performs in reality and in practice. Again, seeing much more preferable early strength development compared with a GGBS blend. Again, setting times, water consistency, more favorable than a standard blended product, and actually the water consistency very similar to a slag blend. Okay, the most important aspect for us now alongside the performance is really where the carbon and the clinker contents come in. So we're seeing a drop off in clinker. We've been able to achieve as low as 37% and still get pretty good results. But for us, it's the 50% or the 44.5% clinker, the 52.5% clinker that makes massive differences on your embodied CO2. So CEM1 for us is about 880 down to your CEM1 or your CEM1 replacement, you're dropping that from 880 down to 570, and a high replacement of CEM2 down to 500 kilos of CO2 per ton. So for us, it's something that's very interesting moving forward, being able to combine that carbon reduction while still retaining good performance. You'll notice that there's a difference between the trial and the pure calcined clay. The trial material with a little bit of contamination with limestone, so we've met with an issue with calcium carbonate decomposition, but again, something we're working on. So really, just to summarize, really happy with where we've got to overall. Essentially, we've taken a research project and brought it to life. The project we're working on the clinker-free cements and expanding that testing to include admixtures and additives to really start to change the property, bring water contents down, and improve workability without sacrificing strength, or vice versa, bring strengths up and try to balance the workability properties. Just an example there of one of the industrial scale trial units we've produced alongside Moore Concrete. So it really is a project that's coming to life for us. And really, finally, we're looking at a route to market now. So looking at 100,000 ton per year production capacity, and then starting to expand that over the next 4 to 5 years, and really expand operations, start to make an impact on the UK market, and maybe hopefully step towards a more non-conventional cements into the likes of a clinker-free cement and that type of material. So thank you very much for having me.